Okay, we do a little bit more discussion, and this portion might be slightly difficult for some of the audience for this video lesson. And what I want to discuss is this. Let's go back to the problem counting number of squares, and eventually we say, okay, you need to add up 1 square plus 2 square plus 10 square. And I want to show you that it's possible to get a simple formula for this sum of squares. Okay, so basically what I'm going to do is give you a different way to count the number of squares, and then we'll get this sum in a quick way. So what I want to do is show you how to get this formula by using a different way of counting the number of squares. So I'm going to count not by the size of the square. I'm going to count in a different way. So I'm going to separate the squares into two types. One type is squares, I say the squares along diagonal. So what type of squares are on diagonal? This one is on the diagonal. So basically it's upper left and lower right. They sit on the diagonal. And these type of squares are symmetric along diagonal. Okay? And these type of squares are easier to count. How many squares are there? Well, it's determined by the upper left and lower right. They're sitting on the diagonal. And basically determined by this pair of numbers on the diagonal. And there are how many points on the diagonal? There are 11 points, just like 11 points on this line. So it's 11 choose 2, basically. So the number of squares are 11 choose 2. I would write 11 choose 2 like this. And this, of course, is 11 times 10 divided by 2. And now the next question is, well, what about the rest? The rest are the squares off diagonal. They are not on the diagonal, so there are two types of squares off diagonal. One is like this one. It's to the upper and the right, and the other one is like this one, to the bottom and low. And because the diagonal somehow separated the whole square into two parts, these two must be symmetric. So I would count just one part, 2 times of the number of upper right side triangles, squares, okay? Upper right side squares, like this square. And how do I count the number of these squares? Okay, I claim that the following determine the square. The this point, bottom right point, and this determines the end, to the up to the bottom right, where the square ends. And then you need to determine the length, and the length is just determined by maybe this point. And the difference of the 2 points will give you the length of the edges. And the bottom right, you have corresponding columns and rows. So bottom right corner give you two numbers. The corresponding column number, and in this case, the column number 1, 2, 3, 4, 5, 6, 7, 8. Column number is 8. It could be as big as 11. And the low number is 1, 2. Okay. And I claim this, oh no, I'm sorry, 1, 2, 3. Low number is 3. And I claim the column number is always bigger than the low number. And that's because it's not on the diagonal, it's on the upper right of the diagonal. That's exactly what it means to be on the upper right of the diagonal. The column number is always bigger than the row number. And then this point always have the same column number, it's on the same column. but it's a low number. So top right, the column is the same, but the low number is different. And the top right, because it's on the top, the low number is always smaller than the bottom. So now we get three different numbers. And the claim is these three different numbers will determine a square. And any square corresponding to these three different numbers. So therefore, how many upper right squares are there? There are, you just need to choose three different numbers out of 11. Okay? So the answer will be, the number of squares will be plus 2 times choose 11, choose 3. And that will equal to this sum. Okay? So in general, you have the following formula by this counting. You have a nice formula, 1 square plus 2 square plus all these squares equals m plus 1 choose 2, because 11 is 10 plus 1, not 10, plus 2 times m plus 1 choose 3. And if you just do the algebra, you will see that it simplifies into n times m plus 1 and 2m plus 1 over 6. And so in the case of this guy, it will be 10 times 10 plus 1 is 11, and 2 times 10 plus 1 is 21, divided by 6. And how do we divide? Well, this, I think it's better to do 10 times 11 times 7 and cancel out the factor of, what do you say, the 3. And this is 770 divided by 2, and that should give us 385. All right, so that's the discussion I want to do.